I don't have any to give you right now. We're going to talk about graphing quadratics. Now, as we go through this, keep in mind we're going to learn over the course of the chapter, 3 different ways to graph quadratics. Don't get overwhelmed with it because you've done the same thing with lines when you learn to graph lines. You learned to graph lines probably first in slope-intercept form, right? Then you learned standard form, and if you didn't learn it back then, you definitely learned it in here because we did a whole review unit. So it's kind of the same thing. We're going to talk about some different ways to graph quadratics in different forms. But first, I want to talk to you about some properties of quadratics, okay? Does anybody know what a quadratic looks like when you graph it? There is an X and Y axis, but... Okay, but you're talking about like the coordinate plane. But, yeah. But what does the quadratic itself look like? And we're talking about, we've been looking at ax squared plus bx plus c. Okay. If I were to graph something like that, what would it look like? This is kind of like if I asked you, if I gave you an equation of a line, y equals mx plus b, and said, what's it look like? You'd say, oh, it's a straight line that looks like this, right? Or this, huh? Nobody knows what a quadratic looks like if you graph it?
No.
Have you ever seen a shape like this?
No. That's like, yeah, this is a function, Miss McGee.
It is a function. Good job.
Good job, Bill. Yeah, no problem. So they only have one output.
Good job. Good job. You did. I did teach you something. You remembered something.
Yeah.
All right. What else? But what's the shape called? Does anybody know? Yes. Thank you. Whoever said that. Parabola.
Will, you a genius.
Okay. Now look, these parabolas can open up or down.
Bless you.
Yep. They can be skinny. They can be wide. Okay.
Can they be curvy?
No, they can only have the one lump in them. Right here. The different colors are different parabolas. You'll graph one at a time. I'm just telling you.
What would you look at more than one?
It's not a parabola. So I'm going to teach you how to graph these, okay?
Yeah.
Now, a couple of important things about a parabola. Bless you. Y'all got this? Let me draw an example, and this will apply. Oh, sorry. All right, look at my parabola. There's a couple special things that I want you to notice about the parabola that's going to help you graph it. Look at it. Tell me something. Think about geometry. Tell me something special about a parabola. Good job. It's symmetrical. Symmetrical means...
Reflection. Same.
Exactly. So what goes through the middle?
The vertex.
Oh, that's good. How'd you know that? But that's not what I was getting at, but that's good, because you're right.
I'm always wrong when it comes to you.
No, it's called a line of symmetry that goes through, but you are right, because the line of symmetry also goes through what we call the vertex of the parabola.
I learned that from Hitchcock.
Right. Or the origin. Hitchcock. You learned from Hitchcock?
I put line of symmetry here. We're going to refer to it as an axis of symmetry. But you're right. It's exactly the same on both sides, right? So the distance from this point to the line of symmetry is the same as the point right across of it to the line of symmetry. Ooh. It wouldn't be symmetrical.
So it wouldn't be a quadratic.
Correct.
Dang, that was.
Okay. All right. So we know it's symmetrical. We know that it has a vertex, and through the vertex, the line through the vertex is what divides the parabola in half, right?
Yep.
Trace your pencil from the left and start tracing the parabola. I'm going what? Up or down?
I got a pen, so I don't know.
Down. Down, 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 down. When do I stop going down?
The vertex.
The vertex.
So smart.
What happens at the vertex? It stops going down and it starts
Going up.
going up. It changes direction at the vertex. Okay, so the vertex is critical. It's a very, very, very important part. Yes?
Blow your nose in.
There's a couple things you're going to have to know how to do without graphing. Okay. One, we have talked about how to identify A, B, and C. Yes? Okay. Without even graphing a quadratic. It doesn't matter what. Yeah, same thing. The A tells us two things. Okay. A is the number in front, right?
Yeah.
If A is positive.
The quadratic's gonna be positive.
Well, close. It's gonna open up. Okay. Think about like positive and happy. It's smiling. It opens up.
Oh, so the quadratic's got they got different points like the 2, 5, and 4.
Yeah, we're gonna talk about how we find those points.
Okay.
Yeah. If A is negative, so smart. It's going to open down. Okay. Now, that's a lot that A tells us already, right? Right. But it also tells us something else. Remember I told you how, bless you, the graph could be, the parabola itself could be real skinny or it could be real wide.
Yeah.
A also tells us that. The bigger that A gets, you would think, right?
No, it's a skinnier.
The skinnier the graph gets.
That's
what Headcount used to talk about, man.
So if you had a really big A, it's going to bring in...
It's a skinnier width. Yes, sir.
It's going to bring in that real skinny graph like that, okay? But as A gets smaller... Now remember, I'm talking smaller, but I'm not talking negative. So if I'm not talking negative, what am I talking about whenever I say smaller? Low numbers like, well, we're going to call, if A is 1, we're going to call that a normal graph, an average graph, okay? So what's smaller than 1 but not negative?
0.1.
Not 0.5, 0.1, what am I talking about? Decimals and fractions less than 1?
So what are we supposed to be writing? Smaller A fraction. See, you got me confused.
All right, so look, I'm gonna recap it, and then we're gonna do a couple examples like this. All right, so listen, DeAndre, sit here.
Yeah, come over here, boy.
All right, so bigger A, skinnier graph. Bigger A, skinnier graph. Smaller A, wider graph. One more thing about the equation before we actually graph, guys, I need you to pay attention. This number on the end that doesn't have an X hook to it. Any guess as to what that is?
See? Who's that? I heard.
You might not know this.
How you know what I know?
That's why you were so good yesterday, man.
This is your y-intercept, okay? It's where it crosses the y-axis. And if you think about it, when we talked about graphing a line in standard form, we talked about if you plug a 0 in for x, that's your y-intercept. If you plug a 0 in for y, that's your x-intercept. So here, if we plugged a 0 in for the two x's, the only thing that would be left would be c, so that's our y-intercept.
So C is our y-intercept.
Okay.
So what does y? So y would have that's here. What is that? What is the other?
All right. So remember, when I'm looking to make sure it's a quadratic, if it's got that x squared there in it and there's no bigger exponent, we're looking at a quadratic. Okay. Let's do a couple examples of what it's going to look like before we actually graph it. B doesn't. We're not going to worry about how B affects it right now. Right now, I just want you to analyze it based on A and C. So I'm going to give you 3 equations. Remember, I said that the average Yes, put a little bit of space in between. When I'm talking about the width of the graph, the average of what I'm comparing to is when A is 1, okay? So look, I know, you're not supposed to be talking to Bill right now.
Stop talking to me.
All right, look at the first one. Tell me this. Does the first one open up or down?
Down.
It's up because A is positive. Okay? Do you see why? Look, do you see why? This is positive. Yes?
Oh,
you
that
see?
is right.
Okay.
I'm looking at number 5. I'm sorry.
Okay, that's okay. That's all right. Tell me, when comparing it to the average graph with an A of 1, is it skinnier or wider than the average?
Wider. Skinnier. It's a fraction. It's skinnier because it's 2.
Skinnier because it's 2, and 2 is bigger
Go ahead, boy.
than
Go
1.
ahead, boy.
I told you I'd be paying attention.
Yeah.
I believe you.
Yeah. Keep that stick away from this table.
All right.
Pay attention.
What's the y-intercept? Where does it cross the y-axis? -5. Look at number 2. Look at the second one. Up or down?
Down.
Why?
Because it's negative.
Good job.
See that, bro?
Compared to a normal or average quadratic graph, is it skinnier or is it wider?
Skinnier. Skinnier. Wider because it's a fraction. Skinnier. Wider, right? Give me that. Give me that. Give me that. I need that.
Wider. Listen, DeAndre, that's always the opposite of what you think. The smaller A gets, the bigger the graph gets.
So A small?
All right. What is the y-intercept?
-1. -1. So that keeps going down.
So it's going down. It crosses the y-axis at -1,
Hold up.
and it's wider than
Matter of
average.
fact, you didn't tell us how it goes up and down. How you determine this?
If the A is negative, it goes down. If the A is positive, it goes up.
Oh, that's how you have to say. That's wrong. That's wrong.
It should go up, right?
Look at the last one. Up or down?
Down. Because it's negative. Oh, up. Positive.
That's a positive. All right. Think before you answer this, okay?
And it's going to be wider because it's a fraction. Well, no, it's going to be skinnier because it's an improper fraction.
It's an improper fraction, and that fraction's bigger than 1.
2.5.
Bigger than 1 is making it skinnier than average, right?
2.5, and it's going to be, your y-intercept is going to be 6.
Good job. All right, do we feel okay with that? Because we're fixing to get to the, yeah.
Wait a minute.
Wait, hold up, Miss McGee.
Yeah.
We ready?
In your house.
All right, so I got you a chart set up here.
You have the
Steps and an example. And what I'm going to do is I'm going to run your steps, and then I'm going to show you in the example how you would apply that step. So anyone you come across in your homework, you can go through this step chart until you get the hang of how to graph it, okay?
Yes.
All right, the first thing we're going to do,
Yes.
identify A, B, and C, okay? So look at my example on the right. And if y'all want to watch me do each step, then I'll pause it, let you copy it, and then we'll go to step 2.
Yeah, I want to.
So that way you're not busy frantically writing while we're explaining. All
A
right.
is 1, B is 1.
No. Look at the example over here and tell me what is A.
2.
2.
B is 6.
DeAndre.
And C is 3.
And C is 3. Ah,
All right. Okay.
1.
here we go. What did we talk about was a critical part of the parabola? Somebody said it. What's a critical part of the parabola?
The A.
Okay, that's we're talking equation-wise the vertex. All right, this is the heart.
You getting graphic.
First thing we're going to do is find the vertex, okay? So there's a little formula. It's a small formula that you have to remember to find the vertex, okay? So the first part, remember we're talking about a coordinate plane, so we need an x and a y, right?
Yes.
All right, so to find x, we're going to do opposite b over 2a,
That's easy.
okay? That's only the x, but remember what goes through the vertex on my graph? The line of symmetry. So if I find the x, then I also have my line of symmetry. So over here, x equals
6 divided
-6
4.
divided by
6 4.
2 times 2,
6 4.
which is
3 seconds.
1.5, -1.5. Okay.
That is not no 1.5. -3 divided by 2.
I got lost.
Where you lost?
If I times 2 by 50, I get 100. I got 3 by 50.
What? Opposite B over 2A. Opposite B.
So when
Over
you get
2.
1.5?
All right. Shh. I'm going to come over to my graph, and I'm going to go -3 over 2, which is -1.5. And I'm going to go ahead and just put this axis of symmetry, because somewhere here is going to be my vertex. Somewhere on that line is going to be my vertex. But I know that's going to be the middle of my parabola.
Right.
Now, before we actually graph, and I should have done this to start with, should my parabola be opening up or down? Look at the equation. Up because it's positive.
The A is positive, so it's going to go down.
A is, shh. We just talked about it opens up because A is positive.
Yeah.
A is also 2. Should it be skinny or wide compared to an average graph?
Skinny. Wide. It's a whole number.
No, it's skinny.
Skinny, opposite of what you think. It's bigger than 1, okay? So it's going to be skinnier. All right. So we graphed our axis of symmetry, but we said a vertex somewhere on here has 2 parts. It's got an x part and a y part, right? So if we have the x part, then we need to plug that x in, plug in original equation. This is still part of step 2, finding the vertex. To find y. Okay? Now look, because this is going to be difficult. I have a fraction, and I'm plugging into this equation.
But where are you plugging it in at?
X equals this, so for every x, I'm going to plug in -1.5. Okay? Or -3 over 2. I'm going to change this for you to -1.5. Darian, please.
2 times -1.5 is 3. It's actually 9. That's what you get.
No. 2 times -1.5 squared plus 6 times -1.5 plus 3. Okay? So here's where you need your calculator.
You can just.
Hold on, let me let you catch. But make sure you can, and you can put this in all at the same time, but you're going to need those parentheses in there, okay? Make sure when you plug that x in that you get, Darian, 1.5 back out.
I'm doing good now.
All right, because if we're going to plot a vertex, we need an x and a y, right? Well, here's my x,
And you got your Y.
and here's my y. So I got -1.5, -1.5.
And you got your slope already.
I don't have a slope with a parabola. This is
I
different.
mean, you got your Y and your
Hold
slope.
on. How you clear my calculator? I don't know how to get this.
All right.
Let's go.
-1.5, -1.5. So I go -1.5, -1.5. This is my vertex. Put a V there because you will get confused as to what's what. Okay? So this is my vertex. The coordinates -1.5, -1.5.
And now you just put a line through it.
Now remember what a parabola looks like, okay? You're going to need 3 points to graph a parabola. So the next point that I graph, what I want to do is I want to choose what I call an easy point. And whenever you do this,
Y-intercept is easy.
think about whenever you graph a line, okay? I'm going to put pick an easy point. Now, Darian says use the y-intercept, and I 100% agree with him because this is an easy y-intercept. It's a 3.
Just saying, Darian super smart.
But what if that was a 13 on the end or a 23?
Go up.
Okay, it makes it a little bit harder though, right?
Yeah.
So
how would it be harder if you just going up?
well, because what if you were graphing and you couldn't go up 13 or 23 or 53 or 103? Yeah. So what you want to do is you want to pick an easy point, okay? If you can use the y-intercept, use it. Well, there's also another scenario. If your vertex sits on the y-intercept, you can't use that as your easy point.
But if
Okay?
you use your y-intercept, 0 and 3, you got 1.5, 1.5 is a point already. You can just do the y1 minus y2 and you can find you another point.
Well, but you're thinking slope again.
If you still do the slope, though, you still gonna
But look, what you can do is you can pick an x, okay? Look, here we had an x. You can pick an x, guys, and plug it in the equation to find the y. And then you have another point. Anything you want. Yeah, it doesn't have to be. So think about like a T-chart like this and pick whatever you want here that's easy to plug in. For us, we're using 0 because we're using the y-intercept, but maybe 1 or 2, whichever you want to use, just stick close to your vertex, okay?
But hold up. See, that's your vertex right there.
Here's my vertex.
And you said you use that point right there.
I'm gonna use, because this is a nice, small, easy number, and my vertex is not on that point, then I'm gonna plot my point
So you can use 3?
0, 3. Okay?
But you have to find a whole
I'm gonna use 1.
If you use 1, let's say we wanted to use 1,
1 times 1 is 1, times 2
DeAndre.
is 2. Plus,
I'm sorry. I'm sorry. Let's say I picked x equals 1. If you pick something that's not the y-intercept, I'm going to have to plug in like before, 2 times 1 squared
Plus 9.
plus 6 times 1 plus 3.
2 times 9.
2 plus 6 plus 3. So this point is 111. Okay? I'm not going to use that because I have this and it's easy.
But then you said you gotta find a whole nother. You said you had 3 points.
I'm fixing to show you an easy way to find the third point. Stick with me. Let's plot our second point. Let's plot our easy point.
No, that could be your third.
So how
that
can
could be
we
your
find
third
them? How
point.
can we find them 2 points?
I'm fixing to show you. Look,
Hold up. That could be your third point. Couldn't it? 111 could be your third point.
it's got to be on the other side of the...
Man, what are you talking about? 111 is over here.
Look, if I do 111, it's going to be way up here. That doesn't tell me what this side of the parabola is going to look like. That's exactly what we're going to do to find the last point. Good job.
No, girl.
You tell it.
The very last thing we're going to do is we're going to reflect that over our line of symmetry and connect all the dots. Reflect and connect. Right, and I'm going to come back to this. I know y'all haven't finished copying it, guys. Please stop and let's get through this. If I look at my easy point, which was here, if I reflect that over this line, it's 1.5 over, right? So I need to go over 1/2 and 1 this way. So does everybody agree I just reflected that? Like in geometry?
Yeah.
If this was a mirror sitting here, where would the dot fall on this side of the mirror?
Halfway.
Okay, so that's all I did. I reflected it.
So what you did was
So you move over 3 times to your my left, your right.
Bowl.
Yes.
So basically what you're doing is whatever your vertex is, you times it by 2 on the opposite side.
Literally just go to the vertex.
Yes, but you're making it too different. Just count.
So just
Look.
make 3 away.
Count over to your axis, and then count that many over that way. So if I was here, then I'd be 1, 2, 3, 4, 5.5. So I'd go a half, 1, 2, 3, 4, 5. That other point would be right there.
Well, I was going half of it.
Because this vertex sits odd, it sits halfway between.
But you said we going all 3 points. Yeah, yes,
So you find the X, you plug it in the vertex,
Yes.
and then you find your Y. Find your Y.
So there's essentially 2 formulas for the vertex. There's the opposite b over 2a, and then there's the original
That's really
formula.
not that much.
Right. It takes a long time for me to teach you initially how to do this, but it's really not a long process. Yeah, definitely.
You need 2 days on it? You need 2 days on it?
If you give me a problem,
Let me go back.
explain the class out.
Talk. I don't like talking. I gotta talk. All right. So we're gonna do the A, which is 2. Is it too big?
It's okay. Keep going. You're doing great.
B, which is -8, and C, which is 6. Okay, and then we're gonna do part 2 where we find the vertex, which is gonna be X equals opposite of B, so it's gonna be a positive A. A positive A, and it's gonna be 2, 2.
Excuse me, Mr. Maxwell. You saying stuff, but you ain't writing it on the board.
Yes, he is.
All right, and then it's gonna be, we'll work it out this way.
Give us a minute to write down.
Yeah.
Mr. Maxwell.
Is he Dr. Maxwell or?
No, you Mr. Maxwell. He that far.
Not yet. Not yet. Y'all scared.
Is everybody good?
Yes, sir, Mr. Maxwell.
All right, so we have 8, 4, which will reduce down to 4, 2. It's 2 over 1. It's 1/2. 0.5.
Bull crap, Mr. Maxwell.
It's 0.5. It's 2 over 1.
It's 2.
2 over 1. So, yeah, y'all right. My bad, guys. My bad. I can't get it all. Okay.
Come on, y'all. Go easy.
2, and we're gonna go to the graph.
Yes, sir.
How do I get to the graph? This one.
Oh, you divide.
Back the other way.
You divide 8 by. Oh, you divide 8 by 4.
Okay, so we have positive 2, which was our vertex. That's right. That's the vertex.
All right, look. He just put his axis of symmetry up. He's got half of his vertex.
He's eating.
Half of my vertex.
He's got to find his other half.
Can we draw the graph?
Can I just go to the next page and clear it?
No, Mr. Maxwell.
Wait, go back.
I need to clear the last page. Go back. What do y'all want me? I'm on
To
it.
your work, Mr. Maxwell.
Oh, you need to go to the work.
Thank you.
Okay, so can I clear this page or
1 second,
erase?
Mr. Maxwell.
Yeah, no, I'm gonna leave the problem up.
Yeah, you can clear the page.
I'm just erasing the ABC
Why, Mr. Maxwell?
because that's what I need to erase it. Yeah,
They're a tough crowd, aren't they?
they are a tough crowd.
Mr. Maxwell, I really learned today in your class.
Yeah.
Okay, now how do I get back to the pen?
When's the test, Mr. Maxwell?
Tomorrow. All right. Now we're gonna plug in. We're gonna plug in our X. What are these buttons on this pen?
If you hover over too long, I don't know. Oh, that's like
The buttons like they stop.
It's like a transformer.
Okay, so
Yeah.
we're gonna plug in our X.
Oh, Mr. Maxwell, I know how to do it now.
Right.
How you got all that?
Oh, my
You plug in your X to your original problem.
Excuse me. What's up?
Mr. Maxwell, I think you should write her up, Mr. Maxwell.
You plug in your original problem and solve it. I have a
Mr. Maxwell,
calculator.
Omega.
No. Sorry, I'm a little hard. Okay, so 2 times 2 is 4, and then you decay 8.
It's negative
That
2.
is-
Oh, that's right, that's right. So you just
It's
calculate
2
it for you.
2 times 2
It's negative
times
4.
2.
I mean, negative 2, Mr. Maxwell.
It's not.
It's negative 2.
And they're giving you the full answer. Keep going. They're telling you what it equals.
Oh,
Oh, they're giving me the full. I was just going this
I
way.
had Mr.
do
Maxwell.
you? Do you?
They just
6
plugged it in their calculator all the time.
plus
Yeah, Mr.
6.
Maxwell.
And then we're gonna, this will be, hold on, let me use my brain. This will be negative 8 plus 6 equals
Mr. Maxwell, can you tutor me on the side?
negative 2. Okay. Now that we have negative 2,
You got it?
that's our y-axis. Y equals negative 2. So it'll be, you'll go back and get your x, which was 2. Then you'll plug in your negative 2. I keep touching every these
Now you
buttons.
stress now?
I don't care. Okay, sorry, that's a little messed up, but it's 2 and then it's 2 and negative 2. And then we're gonna go over. Oh no, we're gonna plot 6 on the y-axis.
You gotta plot your vertex too.
Yeah, that's what I'm.
That's on Mr. Maxwell.
So we go up. God. Okay, so we go up. We're gonna go up 6, right? That's the right.
That's your y-intercept, but you gotta plot your vertex first.
I gotta plot my
Where in the heck?
2.
Where in the crap you get? Oh yeah, see that.
That's your C.
No, I didn't. No, I didn't, Mrs. James.
Is the pen quit working?
Yeah.
Unscrew the end just a little bit.
Why is it negative 6? I thought it was supposed to be a positive 6.
The other end.
The other this end.
Just a little bit. Now screw it back on.
That's the negative 2. So how you put this up?
Still not working? The batteries, you might just need to check the batteries. Unscrew it and check the batteries. They're all good. I don't know why it's doing that.
What? I don't know why, but when it's from him, it's when
Ain't no way that's gonna style up these batteries.
Hey, what you said about me? All the dudes in the green shirt?
That's stylish.
Yeah.
Bro,
I got you, Mr. Maxwell.
no, it's like it's not working.
I'm gonna show you.
Did you break my pen? Here, use Gil's homemade style.
Ghetto style.
Ah, sorry.
Alright, I gotta touch the paper.
Oh, there go Mr. Maxwell. I gotta work it, Mr. Maxwell.
Okay. Okay.
Alright.
Now I need to erase.
Stop touching with your hand. That's why you got the pen.
It's easier to do with my hand. Okay, now this is our vertex, which is 2, negative 2. And now we're gonna plot, or we're gonna go back, we'll go forward. Now we're gonna plot our,
Attention guys, class is not over.
now we're gonna plot our y-axis, which is 6. And so we're gonna count up 6. 1, 2, 3, 4, 5, 6. Y-axis, which is 6. And we're gonna reflect over. So we're gonna go over, we're gonna count 1, 2, and then we're gonna count the other way 1, 2, and that's our answer.
Good job. Connect them.
Okay, now you gotta connect.
You were so smart, Mr.
Oh, give him a hand.
Tell them, it's not